Okay, I think I'm recording now. Yes. Okay, so now we're into strategic interactions in an oligopoly. Okay, and I guess I want to ask, have you guys been taught game theory before? And that's something that's an important thing for me to know. We will be talking about game theory right now, and again, I want to communicate that the Corno model and the Bertrand model, pareho sila, are actually just applications of the same concept, but in a very specific context, okay, which is price competition or quantity competition. So have you guys had an encounter with Nash equilibrium and the notion of what a strategy is before? And that's something I'm interested in, so please write that in the chat. Okay, so many real-world firms belong to oligopoly, right? So firms have rivals, and they have this interaction with their rivals in the market. So sabi ni Patricia, those who have taken 104, and 104 I suppose is game theory. Is that most of you or just a few of you guys? Does it, depende kung available, kung may, I guess ganun siya, no? Kung available and kung may space, if I understand things correctly. It's not required, si 104. Is that not required or is it required? So firms are aware that its actions affect others and therefore prompt reactions. So dito tayo nagkakaiba sa perfectly competitive model. So bumalik ulit tayo sa perfectly competitive model. In perfectly competitive model, there is no strategic interaction because each firm is too small to affect the market demand. Sa pure monopoly naman, we said that the firm is large enough to influence market demand, such that the monopolist is basically choosing a point along the market demand curve. This one is sort of a middle ground wherein each individual rival can affect others in that it would affect the residual demand or the demands that's available to other companies or to other firms, to other rivals. So each firm, instead of being a perfectly competitive firm, each firm will have, if it sets its price to something, it can affect others. And if it sets its output to something, it can also affect others. Game theory is the analytic framework to formally analyze strategic interactions. Okay. So the study of oligopoly is a specific sort of application to game theory. So game theory is divided into two branches. Non-cooperative games is the unit of analysis in that the individual decision maker or player is the firm, okay? And cooperative games where the unit of analysis is a coalition of players or a group of firms. Now, the rules of the game define how competition between different players or firms take place. In a non-cooperative setting, okay, such as what we're going to discuss right now, each player is just concerned with doing as well as possible for himself. So each one will seek to maximize his or her own profits. Okay. Of course, with the understanding again that other people's decisions can affect my own profits. Okay. And that's the whole concept here of strategic interaction. So two basic assumptions that underlie applications of non-cooperative game theory to oligopoly. Firms are rational. They pursue well-defined goals, specifically profit maximization. They apply rationality to reasoning strategically. Each firm uses all information it has to form expectations regarding how other firms will behave. So this bullet really encapsulates what I've been talking about, right? Because each firm will need to sort of guess or have an expectation about how other firms behave. how other firms behave can affect the demand that it faces, and therefore it needs to be able to form those expectations so it can have an expectation as to what demand will look like after everyone else has done their moves. Now, there's no single standard oligopoly model because there are different rules of the game. Okay, so this is something that's quite interesting, maybe a little flabbergasting, right? Because there are different rules to the game. There's number of players, the information, the timing. Okay, that's gonna be different, right? And even if the timing, so for example, right now for the next week or two, we'll be talking about what's called static games, and the idea here is everyone meets in a market and everyone decides simultaneously as to what they're going to do. So parang simultaneous actions. So that's the timing question. Okay, and then later we'll be playing with a number of players, number of firms. And this one, in the three models that we have here, the two models, Cournot and Bertrand, were just playing with what actions are possible. Okay, what is the strategic variable, quantity or price? And then there are others later on, which we'll also be talking about, called the Stackelberg model, which is the quantity leadership model. We'll also be talking about the price leadership model maybe later on in the month. Wherein may timing siya. There's a two-stage game, right? Where one decides one thing first, and then the second stage as another decision has to be made. Okay. Or in leadership, one firm gets to go first, then everyone reacts to that first firm or that leader's actions. Yon. Okay. So there's a lot of things that you can play with, and surprisingly, or perhaps not surprisingly, small changes can have big effects on welfare, on profits, prices, and quantities. So dito na tayo sa game theory. And again, I don't know who else has done 104 para lang alam natin. So mukhang not everyone has done 104. Probably not anyone since walang sumagot. This is basically, so some of you guys might be at an advantage, okay? Because some of this might be something that you already know. Okay, so a strategy is each player's decision or plan of action. Okay. Strategy combination is a list of strategies showing one particular strategy choice for each player. Okay. So remember, the simplest setup here is like there are two players. And the simplest strategy space here is that there are two actions. Okay. And then a strategy combination can say, Gabby up and class down. Because up and down, right? Yung actions. And then a strategy combination will be a particular player and a particular choice. So pwedeng Gabby up, class up, Gabby down, class down, Gabby up, class down. So there's 2 by 2. So it's a four ways in which the combinations can happen. Okay. Now the outcome of the game describes the payoffs or final gains earned by each player. So here we will focus specifically on firm interaction. So we will interpret these as firm profits. But as you can imagine, maybe if you took 104 before, that doesn't necessarily mean that dapat profits ito. It can be any sort of thing that you're trying to maximize. Now the equilibrium, and this is the perhaps most important part here, this equilibrium, is a strategy combination such that no firm has an incentive to change the strategy it is currently using, given that no other firm changes its current strategy. Okay, so this is the Nash equilibrium, essentially. Kaya siya John Nash, or the Nash equilibrium strategy. So Nash developed the notion of equilibrium strategy for a non-cooperative game. So in our oligopoly games, the firm's strategy focuses on either its price or output choice. So similar to a monopolist, okay, the monopolist can choose the price or the quantity. And it's the same here as well. Okay. Corresponding Nash equilibrium will either be a set of prices or a set of production levels, each one for each firm, for which no firm wishes to change its price or quantity, given those of all the other firms. Okay. So in a sense, that's why equilibrium siya. Because say once people have decided, so for example, if it's, why is it an equilibrium for me, for Gabby, right? Gabby versus the class. It's an equilibrium for me because once the class has chosen a particular action, say a particular decision, okay, if I play a particular decision, I, as the firm who we're, I as the person who which we're talking about, don't wish to change my decision afterwards. Sandali lang, pause muna tayo. Okay, so I'm back. Lumipat lang ako ng kwarto. Yeah, so the price strategy outcome will differ from the quantity strategy outcome when firms interact strategically. So that's one of the big ideas here in this chapter, right? That if the strategic lever or the strategic variable is price, iba yung market outcome than if it's quantity. Okay, so this bullet here sort of previews yung results ng slide na ito, which we probably won't finish. Ng set of slides na ito, which we probably won't finish. Rational strategic action requires that firms recognize the actions of others. So it will affect you, and not only that, you should be aware that it affects you and you should react accordingly. Firms will understand and anticipate the chain of events that their actions will trigger, and therefore the firm will include this information in making a decision on whether or not to undertake that action in the first place. In anticipating the response of its rivals, oligopolists will use the information regarding the structure of the market, strategy choices available, and business savvy and experience. There is a time dimension to the interaction. Okay, so it's important in determining the outcome of the game. So we were talking about this earlier about the things that can change when it comes to analyzing oligopoly models, right? So the time dimension is particularly important. So first, there are sequential games where each firm moves in order. When its turn comes, it must think strategically about how a course of action it is about to undertake will affect the future action of the other firm. So especially if it's the leader. So if you imagine, if you're the leader, then you get to set a price first. Then that will influence in the next period other firms' price decisions. Same thing with quantity. If I get to choose the quantity today, and then tomorrow you guys can react to that quantity, then, like with certainty na siya, right? Now there's simultaneous games. Each firm moves at the same time. thereby acting without knowledge as to what the other player has actually done. Okay, so medyo fine yung difference ng simultaneous games because we've said earlier that even in a simultaneous game, now I have to guess or I have to have like an expectation about what other firms are going to do. And in equilibrium, those expectations are met in simultaneous games. Okay. So I as a player in an oligopoly market should have this sort of expectation. So the difference between that and in sequential games is that if I am a follower in a sequential game, I don't have the expectation anymore. Okay, at least not for the leader, because for the leader it's a given. That's already something I am definitely with perfect certainty maximizing against. As the leader, though, you should have expectations about what the followers would do, and that should also influence you, right? In when you set the initial price or set the initial quantity. So that's what it means here when it says when a term comes, it must think about how its action will undertake the future actions of other firms. Okay, so even in sequential games, the leader basically has to have these expectations about what the followers will do. So being rational means a firm's choice of strategy is the optimal choice against the anticipated optimal actions of its rivals. Okay, so that's just essentially what we've been saying. Even if it's sequential or static, I still need to have this sort of expectation in general about other people's actions. And then my own strategy is the optimal response against this expected optimal choices of everyone else. Such that when each firm does that, and when each has, as a result of rational strategizing, correctly predicted the choice of others, who will obtain a Nash equilibrium. Okay, so here we have the two basic, well, a basic idea in game theory. Have you guys encountered dominated strategies before? Depends. I'm wondering kasi how advanced you guys have been in 104. Is 104 like the entire class, game theory? Or baka walang nag 104 kasi, kaya hindi nyo rin alam. Tama ba? Okay. Anyway, if that's the case, kung walang nag 104, oh, but I guess my question is, sino yung nagturo ng 104? It's Micro 2, game theory as a topic. So walang Nash equilibrium. Maybe at least umabot kayo sa concept ng Nash equilibrium. Meron naman. Okay. Okay, so we'll talk about now dominated strategies. Okay. Now, a dominated strategy is a strategy for which there's always an alternative that yields a higher profit than the strategy in question, than the dominated strategy. Okay. Such that firm A's strategy that is never profit maximizing regardless of the choice made by firm B. So whatever firm B does, firm A, if firm A has a dominated strategy, that just means that no matter what firm B does, firm A will never do the dominated strategy because there's always an alternative that yields a higher profit. So a dominated strategy should never be rationally chosen and will never be included in an equilibrium strategy combination. So the reason why we introduced the concept of dominated strategy is it's a way to solve a game theory model on that. Once you've identified a dominated strategy, you can eliminate it, and because it will never be used. So you can only focus on the strategies that have at least a chance to be used, okay, to meet the definition of Nash equilibrium. And the dominated strategy will never be used because there'll always be a better action regardless of everyone else's choice. So dominated strategies can be eliminated one by one. Once the dominated strategies for one firm have been eliminated, we can turn to the other firms to see if any of their strategies are dominated given the strategies remaining for the first firm examined. So iterate until only non-dominated strategies remain. Okay, so this set of bullets here talk about how to implement itong dominated strategies elimination as a way to solve a game theory model. So once you identified one dominated strategy, you can like cross that out. And then you can look at other firms and say, okay, given the fact that Gabby will never play up and Gabby will only play down, meron pa ba akong dominated strategy? Okay, blah, 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 blah. So iterate until only the non-dominated strategies remain, and sometimes isa na lang yung matitira for per player. Sometimes. And in that case, you can get your iterated dominant equilibrium. So here we have an example of two airlines, Delta and American. There's a flight from Boston to Budapest. Same price, but the departure times are different. Okay. Strategy choice is departure time. Okay. When you will fly. So the two firms choose departure time simultaneously. The choice of departure time depends on consumer preferences. Firms are assumed to know the distribution of consumer preferences. 70% prefer to leave in the evening for a morning arrival in Budapest, and 30% prefer a morning departure. If two firms choose the same flight schedule, they split the market. Each wishes to maximize its share of the market as this is proportional to profits. So that's the setup. So all they're going to do here is to decide whether they'll fly in the morning or in the evening. So this table here on the right, okay, is the normal form representation of a game. So American Airlines are columns, morning or evening, yung kanilang actions. And then Delta Strategies is morning and evening. The pair of values at each row or column gives the payoffs for each carrier if that particular strategy combination occurs. So if American and Delta both fly in the morning, they get 15 and 15 as their profits. If American and Delta both fly in the evening, they get 35 and 35. The first value of each pair is the payoff, that the market share that goes to Delta. The second is to American. So again, this is something that a convention siya. The left side is basically the person on the left here. And the right-hand side number is the column person. So what's interesting here is about the morning and evening, if they both diverge, right? If American flies in the morning and Delta in the evening, okay, Delta gets 70 and American gets 30. And it's the opposite if they both diverge 30 and 70 here. So what's happening here is yung distribution of firms. Okay, that's it. Let's see how we're able to fill out this table, right? So we know that if only one flight leaves in the morning, then 70% of the market will go to that airline if it's the only one to serve in the morning. Which is why if American plays morning and then Delta plays evening, and 70% is the evening market share, Delta gets 70 and then American gets 30. Okay. So in a sense, one interpretation here is you can see that they've sort of divided the time such that each firm can get the entirety of the demand at that time, right? Because there's only one firm in the evening and then one firm in the morning. The evening firm gets 70 and the morning firm gets 30. If they both go at the same time, then they will divide the market that happens to leave at the time. So if they both serve the morning, then this 30 gets divided between the two proportionally. And then the same thing for evening.
70 divided by 2 is 35. That's why it's 35, 35. Okay, so any questions about this one? So this is exactly how we derive this one based on the information that we have here. Okay, these two bullets. Okay, so typically you're able to do that after a few. You just need to know what the payoffs are per combination of strategies, which should be easily describable in text form. And this is how you are able to also easily describe it in a table form, called the normal form of representation of the game. So let's start analyzing this game specifically. So si Delta, if American flies in the morning, Delta can choose between morning or evening. So here we're asked to focus on this column because suppose American flies in the morning. So the only question is what happens to Delta? Morning or evening? Now, according to this, if Delta does morning, Delta will get 15. That is, if America flies in the morning, if it joins it in the morning, it gets 15. If it separates and sells in the evening, it gets 70%. Meanwhile, if American flies in the evening, if morning, it will sell 30. If evening, it would get 35. So first question, any questions about this? Okay, so we're basically focusing on one column at a time, focusing on Delta's decision. And mabalik tayo dito sa concept of dominated strategy, a strategy for which there is an alternative strategy that yields a higher profit than the strategy in question, regardless of the choice made by firm B. Firm B here is American. So ginagalaw natin yung strategy ni American. Sulitin natin. If American does morning, what is better for Delta? Morning or evening? Okay, ulitin natin. If American does morning, focusing on this column, what action is better for Delta? Morning or evening? And why? Evening because what two numbers are you comparing here? 70 versus 15, correct? Okay. And sort of the logic is clear. Like we said, kung morning, makikisaw-saw ka sa morning, you're just going to share the 30. If you separate and choose the evening, then you will get 70. Okay. That seems to be quite clear. Pag evening naman, let's say American definitely flies in the evening. What's better for Delta? Morning or evening? Still evening because 35 is greater than 30. So the numbers were generated such that even if you divide the large market here, such as 35, 35, it's still better than if you sort of monopolize the morning market. Okay. Delta does better by scheduling an evening flight no matter which departure time America chooses. Choosing a morning departure time is dominated by evening. So that's an example of how to find what the dominated strategy is. So for Delta, you can eliminate morning. Now, if you eliminate morning for Delta, so nasa evening Delta na tayo, what's better for American? Working on the iterated dominant strategies. What's better for American? So given that Delta won't play morning because morning is a dominated strategy. Therefore, it for sure will play evening. What should American do? And what two numbers are you looking at for American? Evening, because 35, the right-hand number here, 35, we compare it to 30. So American will also do evening, okay? Because these 30 versus 35. Given that you know that evening will be played by delta, American will basically just compare 35 to 30. And 35 is better. In fact, this set of slides here replicates the same exercise in that this time, si American naman yung nade-decide, and then we're decide American will sort of, what if delta did morning and what if delta did evening? Okay. And for American, choosing a morning departure time is a dominated strategy as well. So the idea that's iterated there is you can eliminate morning for delta, and you can eliminate morning for American, and that leaves you evening and evening as your Nash equilibrium. The only equilibrium outcome for this game is to have both airlines choose an evening departure time and share the 70%. This is a Nash equilibrium by virtue of the dominated strategy argument. No carrier will change their choice because neither carrier would ever choose a morning flight time in any case. Our next concept is dominant strategy. So dominant strategy, a strategy that outperforms all of a firm's other strategies, no matter what a firm's rivals do. It leads to higher profits, no matter what its rivals do. It does not imply that a dominant strategy will lead the firm to earn higher profits than its competitors, but that the firm will do the best it can if it chooses such a strategy. So this is related to the dominated, but it's sort of like the inverse, right? So no matter what others will do, there is one strategy that you should do. So in this case, in the 2x2 idea, once you've identified a dominated strategy, you've automatically identified a dominant strategy. So it's a 2x2. But in a more complex situation with like 3 actions, that's not necessarily the case. A firm may have some dominated strategies, but not have any dominant strategies. Or a choice that yields a better results than all, or it could have a choice that yields better results than all the others. Also possible that a firm will have neither a dominant or a dominated strategy. However, a firm with a dominant strategy should use it, and it's part of the set of Nash equilibria. So in this table, we have an example with no dominated and no dominant strategies. So some of the potential Boston to Budapest flyers prefer Delta because of its frequent flyer program, even if the two fly at the same time. Flying at the same time does not yield an even split. Delta gets 60 and American gets 40. So let's look at that. So let's say morning and morning, they fly at the same time. 18 versus 12. Okay, so Delta gets more. Yung market share niya is 60% of whatever's left. And the evening, if they fly at the same time, it's 42-28. This sums to 70 and this sums to 30. But of the 70, Delta gets 60%. However, if they separate, they still essentially corner the market. They have market separation. 70 to whomever is flying in the evening and 30 for the morning, and the opposite happens. So let's analyze this thing. Okay. So Delta, the evening flight is still dominant. Okay, so can we check that? So for Delta, the evening flight is still a dominant strategy. So evening, no matter what American does, is evening the best thing that Delta can do? So we can check that. First, you compare 70 to 18. And yes, 70 is greater than 18. So if American happens to be going in the morning, then evening is Delta's best response. Let's say American were to go in the evening, 42 is still greater than 30. So Delta says evening. So evening is a dominant strategy, and for Delta, morning is dominated. But what about American? If Delta chooses a morning flight, it would be better for it to choose an evening flight. And if Delta chooses an evening flight, then it should fly in the morning. The game's outcome is still clear. America knows that Delta will always choose an evening flight. So my first question is, how does America know that? So first question, how does America know this? Anyone in the chat? Because evening is the dominant strategy for Delta. And because Delta has a dominated strategy and a dominant strategy, Delta is for sure will choose evening. Okay. So America's best response, given the fact that it expects Delta to choose evening, is to choose the morning. Okay. So this is Nash equilibrium. So that you can confirm that if Delta chooses the evening, what's a bigger number, 30 or 28? The answer is 30. So American would want to go to 30. Fly in the morning, and then they would essentially separate. So in solving the previous games, we used the ability to rule out dominated strategies, and when possible, focus on dominant ones. And here I repeat, pag meron kang in a 2x2 game, once may dominated ka, meron ka ng dominant. But that's not true in general. In many games, there are no dominant or dominated strategies can be found. In such cases, the Nash equilibrium concept becomes part of the solution procedure itself. Wow, what does that mean? Remember that Nash equilibrium means that conditional on all other choices, I have no incentive to change. And that we have to check that for all the different players. Okay, so we have to find a combination of strategies such that per player, once everyone has chosen this candidate equilibrium strategy, I have no incentive to change my own decision. Okay. And kailangan hanapin yon per player and per combination of strategies. Rational strategic firms will use the Nash equilibrium concept to determine the reaction of their rivals to their own strategic choice. In order to understand more deeply how to use the Nash equilibrium concept to solve a game, we can change the airline game to a game in prices here. So here are 3 prices, low, medium, and high. Still 2, right? Still 2 players, but 3 actions. Okay, 3 actions which correspond to 3 different price levels. 3 by 3 will yield 9 strategy combinations, which are indicated here. So we can look at this first. If everyone chooses the same prices, low, low, medium, medium, high, high, which are the diagonal, these are the prices here. Again, the left side is for Delta, the right side is for American. If someone sets a higher price than the other. So let's say Delta sets a higher price than American. Okay. You would see that here in the lower diagonals here. Okay. The lower triangular, I should say, not the one below the diagonal. So in this case, Delta has a higher price than American. Delta would have a lower profit. And then if it goes even higher, its profit will go even lower. So 22 versus 20. Well, actually, if its price is higher, its profit will go up from 22 to 15. But when its price goes even higher, it will go down from 22 to 20. And if you notice here that as Delta increases its price, American benefits for sure. And this is something that you will see in the oligopoly model. So this is why we've introduced it here. Okay. Ito yung strategic effect na sinasabi nila, that if Delta's profits are affected by whatever, American's profits are affected by whatever Delta does. So you can see that here as Delta increases its price, American profits tend to go up, right? 15, 25, 40, 22, 35, 38, 20, 30, well, unless it's high, 20, 33, and then it goes down again. Because in this case, they'll have the same price. So now we will study Nash as the solution concept. So one approach is to check each cell to determine if it satisfies the Nash equilibrium requirement that either or neither airline wants to change its strategy. So PD equals PA equals low is not a Nash equilibrium strategy. Can we figure out why it's not a Nash equilibrium strategy? If Delta sets low and American sets low, and we're here, can American do better? Supposing that Delta plays low, can American do better? So we're here. And look at it from American's perspective first, because I'm a column guy. It's beginning to look over columns. Should American change its strategy, its action from low to something else? Yes. Okay. Because higher price, okay, will lead to a higher profit here. 22 to 15. In the same way that if American is here, what should Delta do? It should also charge a higher price, a slightly higher price to medium. From 20, it will get 22 instead of 15. So now let's look at PD. Delta is medium. And then PA is low. So nandito na tayo. Is this Nash equilibrium? May sagot na dito, but then it's not, because Delta cannot improve, because if it charges a higher price, its profits will go down given that American is low. And then if American is low, if its price is low, then its profits will also go down. So Delta is fine. But then American do they want to price low? If they know that Delta prices medium, the answer is no, because if they change their price to medium, it's gonna go from 25 to 35, or even if it prices at high, it will go from 25 to 33. If American did this and chooses medium, PD equals PA equals medium, this is the Nash equilibrium here. And it's the unique Nash equilibrium. Okay, so let's check. Again, ito yung sinasabi natin they have to check, right? Let's say American prices medium. Will delta want to change its strategy from medium to either low or high? And the answer is no. 33 versus 35, 25 versus 35, it will want to stay in medium. If delta then chooses medium, given medium, does American have an incentive to change to low or to high? And the answer is no. 35 is bigger than 25, and 35 is bigger than 33. So given the other person's strategy, each firm has no incentive to change its decision. And that gives you the Nash equilibrium. Okay, so next slide, more appealing approach. Okay. Strategy of setting a high price is never a best strategy for either firm. If both are high, PD high and PA high are each dominated strategies for each firm. So dito pumapasok yung iteration of dominated strategies. So first, can we show that high is dominated? Yes, because 20 is less than 22, 33 is less than 35, and here I'm just looking at the first number, so that's delta. 30 is less than 38. So PD high will never be chosen by delta. In the same way, 20 versus 22, 33, 35, 30, and 38. Once you do that, you'll see that if you eliminate that, you'll see that low and low are each dominated respectively. The spilling of the dominated strategies allow us to reach this equilibrium here, which is the unique Nash equilibrium of the game. So if players are rational, the game will not evolve along the path suggested by the first approach. Given the players know the payoff matrix and the rules of the game, each should choose a medium price from the start. Delta management will see that the American would never set PA high, since it would recognize that this is a dominated strategy for American. Thus, it would restrict Americans' possible choices to either PA low or PA medium. However, American would only choose PA low if it thought delta would choose PD equals high. But looking at the same table, American would see that whether it sets a low or medium price, delta does better by choosing PD medium. Therefore, it would be foolish for delta to ever set, foolish for American to ever set PA is equal to low. Thus, delta can set PD is equal to medium with complete confidence that American will do the same thing. When delta's choice of PD medium is revealed, the predicted American strategy of medium is in fact precisely the choice American would want to make, given delta's choice PD is equal to medium. American will follow the exact logic, but in reverse. So Nash as a solution concept. As a result, each firm will result a medium pricing strategy from the start. There will be no action or reaction that will converge to the medium combination. The fact that each firm's strategy choice reflects its best response to the choice predicted for its rival, which in turn is the rival's best response to the firm's own selected strategy, that gives the Nash equilibrium its power to predict. By true power, it means the power to predict what the outcome of the model is. In the remaining 10 minutes, let's begin with the Cournot model. Okay, so this is something that's super familiar because we already know profit maximization. Everything that we've learned so far about strategies, dominant strategies, the Nash equilibrium, it will find itself here. Okay. Now, single period static game. So it's the same thing as that price setting game earlier or that morning or evening game we had earlier. Firms are assumed to meet once and the market clears once and for all. Okay, historically, this has been around for a long time. It's now usually determined to be Cournot-Nash or Bertrand-Nash because these models recently incorporated the Nash concept as a way to sort of explain how it's explain the result. So rules for Cournot and Bertrand, meaning they both are static games, except that Cournot, the output level is the choice variable, and Bertrand is the firm's so for Bertrand, the firm's price is the choice variable. We will talk about Cournot right now. So the model is developed along these lines. Suppose an incumbent monopoly supplying a market. Single firm wanting to enter. Entrance product is identical to the monopoly. Also the same unit cost. Entry is attractive. The monopolist is producing where price equals greater than marginal cost, which means price will also exceed the costs of the entrant. The entrant will choose an output level that maximizes its profits after accounting for the output being sold by the monopolist. Okay. With entry, incumbent will react, re-optimize, and choose a new output level that maximizes profits given the output sold by the new rival firm. Okay, iterate this process for each firm, choosing an output conditional on the other's output choice. For each output choice of the incumbent firm, the entrant, firm 2, is shown to have a unique profit-maximizing response and vice versa. So this is the Nash equilibrium concept itself, right? So for each choice by the incumbent firm, the entrant has a unique response to that. So what we're trying to do is come up with a combination of outputs such that no one has the incentive to change. Okay. And we'll see how it's done. Very interesting. Using what's called the intersection of a reaction function or both reaction functions. Because a reaction function is defined as the optimal choice. Okay. Optimal choice of the entrant with respect to each output choice of the incumbent firm. That's why it's called a reaction of the entrant. Or in this case, there's also a reaction of the incumbent to each output choice of the entrant. Game. So the graph representations are called reaction curves. And each one is graphed in the Q1, Q2 quadrant. Okay. So Cournot anticipated Nash in the sense that he described the equilibrium outcomes of this process as a pair of output levels at which each firm's output choice is the profit maximizing response to the other firm's quantity. Equilibrium price resulting from output choices is below that of pure monopoly outcome, meaning mas mababa yung price than the monopoly outcome. But it's still higher than the perfectly competitive outcome. The Cournot model carries the intuitive implication that more competition is better than less. Okay, so let's start. I guess we can end here. Okay. And then we need to really hammer down the concept of a reaction function, because a reaction function really underscores the concept of Nash equilibrium. And that you need to search for levels of quantity such that no firm, once those levels are reached, no firm would want to change their quantity. And that's essentially what the intersection of the reaction function is, because each reaction function is the optimal response given some output level by your opponent. So in some senses, that's the same. Calculating a reaction function is the same thing as, conditional on delta flies in the evening. What should I do? Yun reaction function ni American. And similarly for delta, given American flies in the morning, what should I do? What's the optimal choice? So those are the reaction functions depending on what the other person or persons are doing. So here's the setup. So here's the industry inverse demand curve. Okay. So ano yung big difference between this and the simple monopoly? Well, the total output Q is now the sum of each firm's output, Q1 and Q2. Okay. Dito pala makikita mo na kung ano yung interaction or strategic effect of each other's. Because if one firm decides to sell more, then the price will go up or go down. Go down because of the negative sign here. And if the price goes down, that sort of affects the decision of the other firm. Mas mababa na yung presyo ngayon. What should I do now? Should I sell more or sell less? Okay. So Q or big Q is the sum of each firm's production. And Q1 and Q2 are the amount chosen by firm 1 and 2 respectively. And then you can see here, that's why there's an interaction because the sum of their outputs affects the market price. You have each firm has the same marginal cost of production, C. So firm 2, let's focus on firm 2. Given Q1, or consider Q1 as given. So this exercise is similar to dun sa normal form. Delta is morning, or American is morning. If delta is morning, what is American's best response to that? So in this case, consider Q1 as given, so some number. Okay. Thus, the inverse demand curve facing firm 2 is the following. Where notice that Q1 is just some number here. So it's just A minus some number because it's Q1 some number times B, which is again a number. The first two firms are taken as given. The first two terms are taken as given, A and BQ. So this whole thing is just some number now. And this number happens to be less than A. So parang bumaba, nag-shift down yung demand as perceived by firm 2. This is what's called the residual demand, right? That's why it's residual, because you're taking out the output here that's being done by firm 1. Okay, so the only impact its Q2's output level has on the price is given by this one, which is Q2 times B1. Okay, so notice what happens here. So if Q1, okay, so for a given Q1 and Q2 combination, ito yung demand mo. Okay. What happens if Q1 grows? Right? What happens if Q1 becomes bigger? Then A minus B Q1 that's bigger happens to be smaller than A minus B Q1 that's smaller. So that's why this whole thing scoots down or shifts down by how much? By the change in Q1 times B. Boom. So this is a graphical representation kung bakit siya tinatawag na residual demand. Because once tinanggal mo yung output ni other firm, which is 1, ito na lang yung matitira sa'yo na demand. That's why it's called a residual demand. Okay, so that's an important concept to note, yung interaction between firm 1 and firm 2. Okay, we can stop there. Basic message is this. For any given Q1, magbabago yung demand perceived by firm 2. And that's how each firm affects each other. In the same way, it's the same for firm 1. Firm 1 will say, consider Q2 as given. So bababa rin yung demand faced by firm 1. So they're both are guessing what the residual demand is given various values of Q1 or Q2, as the case may be. Okay, so dito muna tayo magtatapos. Any questions? So we will continue next week. And I will upload these slides and upload the recording.